So my name is Chris Crabtree. I'm the co-founder of a company here in Utah, in the United States, called Joot. And you might be wondering, how did we come up with that name? And so I have this kind of little quote here that I've put up, which was something that was quoted on our website. And we discovered this term called Jootsing after we named the company. So this wasn't something we'd found first and then named the company. We thought it just was interesting how it coincided with what it was that we did as a company. This idea of jumping outside of the system was really intriguing to us. That's what we were trying to do with what we were trying to design. But also, when I think of it from the perspective of us using serverless to design and architect our technology stack from the beginning, was literally jumping outside of what is the typical system for doing that. So let me just move forward and tell you a little bit about more that what Joot does, why we decided to build and design it like we did, but what was the story around what kind of problems does Joot attempt to solve, and why did we use serverless to try to attempt to solve those things. So in August 2020, I started this company with a former partner of mine. I had started a company back in 2007 called Mozenda, which was a platform designed for doing web data harvesting. So data extraction, unstructured data, structuring that data, and then providing it in a useful way or an intelligent way for our clients to be able to consume through APIs. And part of that project, near, I think, the 2000 or probably the 2019 timeframe, there was a client that was brought in. My partner told me about that was a speedboat company. One of the things they wanted to try to do is to analyze their social media content against their competitors and see what it was that was causing their competitors' engagement to be so much higher than theirs was on social media. He hired a few data scientists and software engineers to be able to build out, to be able to extract all of the content, to be able to build some models, to be able to run the data through those models and see if they could come up with a predictive model that could help them analyze that market and see what were the engaging concepts that company could adopt. That gave birth to this idea for Joot, which was, could we create a platform that would allow clients to come in who were active in social media and advertising, very active in producing web content and images, and produce what would be called like a playbook or some kind of insights that they could use to predict how engaging those images would be on their markets. This gave birth to Joot, to this idea. Could we build a system to do that? Could we make it so that it was scalable, so that we could build models that were small enough that we could train models using SageMaker and whatnot that would be small enough for us to be able to run within Lambda functions, and to be able to consolidate that in a way that was fast to develop, as low cost as possible for our clients, and as quick as possible. And so from the beginning, we decided to go with the serverless framework. I'm going to share my screen really quick just to kind of give you an overview, and so that you can see what it is that we built and how it's used. Okay. Here we go. So one of the things you do as a client when you sign up for Joot is you define, there are a number of markets that you can choose from. We have over 100 different markets that we've defined based on competing Instagram accounts. Those markets are divided into different industries, but one of the things you can do also is define your own market. So you can define a list of competitors that have active social media accounts. You can put those into a market you define. Our system will go in and then build, extract all of that data, or pull all of that data down from those Instagram accounts, process all of the images through a pipeline that I'll show you in just a minute, how we did that, and then build a model in SageMaker to be able to use to predict what the scoring or how engaging images would be if they were used in that market. This is one of the features we have called Image Insights. What this does is give content curators and content creators the ability to see which type of images in that market are the most engaging for that audience. You click on these different categories here. This is what the model has come up with to after scanning all of the thousands of images in a given market, it finds correlations or concepts that are common that are engaging amongst 2 to 3 images that it finds that have correlations. So creators can come through here and see these are the highly engaging concepts that I want to use when I go to create new content. But I can also see what the low performing concepts are. So I can come in and see, well, these are types of concepts I should avoid when I'm trying to create content as well, because these disengage my audience. One of the other features we have is the ability to upload images that you've probably unpublished, and those images will be ranked and scored against that custom model that you've built as well. So images that have green circles are ones that are likely to be more engaging, yellow are going to be average, and red would be ones that you would avoid trying to use. So we can actually predict what those image engagements are going to be using those models that we've created through the system. Okay, so if we go back and share, Stephen, if you don't mind sharing again the slide, I just want to give you kind of a brief kind of view into how we use serverless framework. This is just a small portion of what the kind of an architecture that we implemented for doing image processing. All of our users are managed using Cognito. Right out of the box, it was something that we easily incorporate into our serverless platform that we were using for doing all of user management. Had all of the features that we needed to be able to do that for authentication. And we use Amplify as the library that we were using in our for our web app, and also Lambda to be able to coordinate that user authentication that would happen both on the Lambda side from the serverless point, from the web service point of view, and also from the web app. When a user comes into the system, you can see here they upload an image that was saved directly to S3 from the website. We then had triggers on the bucket that would go in and pull that image out, resize it, do some processing, pull metadata out of that image and store it into DynamoDB, where we would keep track of that user's image that was uploaded into their library, depending on the bucket that they uploaded it into. One of the things we wanted to use from the very beginning was rely heavily on event-driven architecture. And so Event Bridge was one of the services that we relied heavily on to be able to communicate between the different web service and microservices that we had defined in our serverless environment. We had, I would say, 5 or 6 different microservices that were partitioned out in ways that would handle customer data, pulling social media, handling images, doing the modeling work with SageMaker, billing, probably able to have different services that all communicated using the Event Bridge event handlers. So we would process an image, and one of the things we knew early on is that there were multiple things we wanted to pull out of an image. We wanted to figure out what the image quality was, what the salience was, what the color of the image was, classification. We used Clarify to be able to pass our image information to be able to pull out tag information using models that they have, and several other processes. As you can see here, what we would do is that event would then place the information about the image to be processed into several different SQS queues, each attached with lambdas that would pull the image out and do their type of processing that they needed to. That all happened in parallel. We could have thousands of images being processed through the system at the same time, pushing that image data into those queues to be processed independently by those Lambda functions. We had to come up with ways to be able to coordinate determining when all of that processing for a given image was completed. Once we determined that the processing was completed, we would trigger another event. That would be picked up by another web service that would check to see if a model had been built for that market, for that particular customer, and then send it to a scoring queue for the image to be scored. That would then take the image and having gathered all of the image processing about the image, it would build a training file or training record to pass on to a model endpoint that had been built for that customer. So in SageMaker, one of the options that you have is to be able to host a multi-model endpoint or single model endpoints. We had single model endpoints for each model that was built for a customer. So when a customer built a model using SageMaker through our system, they had their own special endpoint to use to score for that market. So the image would be scored on that. It would throw another event saying an image had been scored. That would be picked up by other services that could then take and rake the image, or to rebuild some market insights based on those image scoring. So this is just kind of a snapshot on how we kind of did our image processing pipeline. What that looked like is just a portion of the way we use serverless to be able to design and implement this type of image processing and scoring algorithms.
Chris, sorry, we got
Yeah.
one question
Yeah.
from Dorian, and his question is, did you consider step functions as an alternative to all the SQS queues?
So definitely, I would say probably halfway through architecting all of this and designing and building it, I took a serious look into step functions. I have no idea how I had kind of bypassed even being really aware of the power that step functions would have given me in controlling all of this kind of sequential processing of the images. If I look back now today, if I were to redesign this and re-architect it, I definitely would have step functions. Would have saved me a lot of time having to try to track kind of the independent image processing that was taking place. So yes, definitely. I would very much consider using step functions to do what I was doing manually through tracking records in DynamoDB. One of the interesting things that happened too when we were doing this is, I'll bring this up because someone might run into this in the future too, like we did. All this image processing, we had a single record in DynamoDB for each image where we would store and append kind of the processing information from each service that was gathering that information for that image. And sometimes it was just small information, it wasn't a lot, but there would be dozens of pieces of information that we would need to update that image record with as it was being processed. And we come to find out that every time you update a record in DynamoDB, it rewrites the whole record. So as that record grows and gets larger, every time you write it, it takes up a lot of the resources that you have in DynamoDB for your number of writes that you can do per second. And so we would quickly run into throttling thresholds when we were processing multiple images, because we'd be writing a little tiny piece of data to an image record, but it would rewrite the whole thing. To get around that, what we did is just had an alternate DynamoDB table where we would store each of those bits of information separately as individual records. And then at the end of the image processing, combine all of those in a Lambda and then do one update to the image record. And that saved us a tremendous amount of resources that we were using DynamoDB to do that. So this event-driven kind of approach, one thing that we found very helpful was that for each event, each microservice that wanted to handle an event in EventBridge, the easiest way for us to be able to kind of architect it in a way that kept it simple was to create handlers, right? And those handlers, as you can see here, are just very simple Lambdas. All they're responsible for within a microservice is to listen for an event, handle the event itself, and then perform whatever calls to other Lambda functions you may have in that microservice. So you may have more than one function on a microservice that wants to handle event, but those separate event handlers came in very handily to be able to use that kind of approach. So why serverless? What were some of the key benefits that we found out? It was really from the very beginning, one of the questions that Stephen wanted me to address was like, well, what were the benefits between using serverless and something else? When we didn't start off Joot by trying something else and then deciding to go with serverless. This was a conscious decision from the very beginning. I knew for me, it was something that I had done a lot of research into, and we needed to develop fast. We needed to be able to get something up and running, and to be able to design our architecture with existing services that would just work. And so, some of these things it was the shortest path to architecture and development and deployment, because it was all in one. I could install it, set up a project, and from day one get something that was up and running. And we needed that. And there was, AWS, and in this case, we chose AWS just because it was something I was familiar with, but it was provided so many different services that were just turnkey services that we could use. For example, Cognito, like I mentioned, or EventBridge, or Lambda, or DynamoDB. We knew from the very beginning we were going to use DynamoDB because of we could define our access patterns very clearly. And we knew that DynamoDB was designed to be able to accommodate that type of data access, if you had a very structured, well-defined data access pattern map for your applications you were developing. We wanted to be able to use multiple languages. One of my partners, who was the data scientist, was coding up all of the code for building the models and training them using Python on his own machine. My job was to take what he delivered to me in Python and then break that out into microservices that could be deployed to Lambda functions. And so half of our project, the project that I worked on myself, which was the API backend, was done in Node.js, but all of the development work for building the models and training them and using, specifically interfacing with SageMaker was done in Python. So having that flexibility to be able to use the same, serverless CLI with two different projects on the same machine using both Python and Node.js was fantastic. We wanted it to be scalable. We didn't know how much we would be growing, how quickly. We didn't want to have to depend on DevOps and worrying about whether or not we had enough resources available. So that was one of the number one factors. And then free tier, we had that ability to start off in a free tier environment with some pretty generous monthly limits to be able to play around with things and not worry about costs getting so high for a startup company. So again, advantages, if I consider the alternatives, we had EC2 or ECS to choose from, which is really just replicating a dev environment out in the cloud, having to manage resources, having to worry about updating the machines, having to do all of the traditional things that so many of us have done before. I wanted to be able to eliminate that. And so the clear advantages were costs. We had that generous free tier limits. We knew that we could track and monitor the cost as time went on. And we could, ask AWS to extend those limits to certain things as we ran into them. If you've never used SageMaker with serverless before, it's AWS prevents you fortunately from getting out of control because it can be costly. Running those models, they do have different, pretty large sizes of instances, and it does take often hours to run and build models in SageMaker. So there are cost factors that you have to consider. Fortunately enough, AWS does limit how much you can use SageMaker from the beginning until you know that you're going to be using it to a full capacity. We didn't want to have any ops. We wanted to be able to define the architecture and code. We wanted developers to be able to understand what was going on and not just focus on code, but be able to understand how that code flowed through the services, what the services looked like, and how to configure them. And then, just overall, we just needed to save time. And the way that you guys have designed and architected serverless is precisely for that reason. And for us, we were able to construct everything we needed within a 6-month period of time, and is wonderful. So anyways, if you guys have any questions, I know I've kind of reached my time limit here, but let me know. I'd be glad to answer anything for you. But also, kudos to the serverless team. Our experience at Joot was just, phenomenal, being able to use this to build this whole thing from scratch.
That's great, Chris. And so one question, and I apologize if you might have touched upon this earlier, was that it seemed like there were like a big variety or a big range of processes, both as far as like processing time as well as like resource requirements and compute requirements. Can you talk about kind of like the variety and range that was necessary, or
right?
that the different functions ran?
Yeah, most of those constraints were in Lambda. We found that we had some processes that needed to run longer than 15 minutes because they were crunching a lot of data. They were having to process a lot of data. We also had some of them that needed to use some pretty heavy modules to load them for doing machine learning type of tasks. And so we would reach that kind of 0.5 gigabyte limitation pretty quickly if we included too many of those modules in some of those Python lambdas that we were writing. So, some of those restrictions now, I know, Amazon just recently announced that they have a higher, I think it's 10 gigabytes of ephemeral disk space that you can have, along with your Lambda when you're using it. So that would have saved us so much effort of trying to what would you say, partition out some of those tasks that were that could have been done in a single Lambda, and maybe divide those over the course of 2 or 3 Lambdas that call each other sequentially. So those were some of the constraints that we ran into. Some of them were memory limits as well, because we're using some libraries that, when you're dealing with big data and you're having to use pandas libraries, for example, to be able to deal and handle records that have often tens of thousands or hundreds of thousands of columns, and then you can reach memory constraints pretty quickly. So there was a lot of monitoring taking place on the Lambdas for some of these. We realized that we could that we didn't need to process as much data to get as effective a model as we needed to for scoring. So we could drop columns that didn't have as high of an impact on the model production, things like that. So there was definitely I would say a month or 2 of time experimenting with really refining the way that we could use Lambda in a way that we could effectively produce the kind of data that you can push the SageMaker. But it's the great thing is, AWS is constantly kind of pushing those back, giving you more resources to use in Lambda, which is fantastic. I think it would be great if we could run a Lambda for greater than 15 minutes. If that was, I know they do that on purposes so that you're not getting runaway Lambdas that you're being charged for. But if you could kind of maybe override that and be able to set kind of a time limit yourself, would be a great feature.